Hey folks, this is the first video that we have in section 2.1 dealing with the library of functions. Before I get into the library, I'd like to talk about increasing, decreasing, and constant. Just a quick note about those. When I ask you for increasing, decreasing, and constant, first thing, you're always going to be using interval notation for that. And secondly, you're always going to use x values and only x values. So go ahead down to the library of functions. A library, these are also going to be called the parent functions, and there's three things that you have to memorize about every single one of these parents. So the first thing is you have to memorize the parent's name. You'll notice that right underneath this, parent number 1 is the identity function, so that's what I mean by the name. Secondly, you need to memorize the equation. So in parent number 1, the equation is going to be y equals x. So that is what I mean by the equation. And then thirdly, you have to memorize the graph, and each graph is going to have a couple of special points that go along with it. So you need to know what the graph is, and you need to know what those special points are. So let's start with the identity function. I've already given you the name and the equation. And we're going to start each one of these by plotting a table of values, although we're not going to do that after we talk about this, because that's the whole point of doing the library, is that it makes our life a little easier when it comes to graphing. We don't have to plot points anymore. So if we have the three x values of -1, 0, and 1, like you see over here on the left, then if I plug each one of those into my equation, you plug a -1 in, you're going to get a -1 out. If you plug a 0 in, you get a 0 out. If you plug a 1 in, you get a 1 out. And so if I were to graph that, that would be these three coordinates here, although that's not quite enough to draw what we need to. So let's think about some more values. If my x value is 2, my y value is 2. If my x value is 3, my y value is 3. 4, 4, 5, 5. On the negative side, if you have -2, your y value is -2. So -3, -3, -4, -4, etc. And once you think about it this way, you can see that you are forming a line. So the identity function is a line, and it cuts the first and third quadrants exactly in half. Now, I would like for you on your own to write down the domain and range for each of these functions. This is going to be one of the things that I'm going to be asking you as your embedded video question. So the domain and the range you're going to need to come up with so that you can write those down for your embedded video question answer in MyLabMath. Let's go to parent number 2, the squaring function. The squaring function is going to be x squared. Think about the three x's that we've already mentioned here, the -1, 0, and 1. If you square -1, you're going to get a +1. If you square 0, you'll get 0, and if you square 1, you'll get 1. So my three values look a lot like this. But again, this isn't really enough to tell us what we need to know. So let's think. I'm not going to write these down, but let's think about some other values. If you have an x value of 2 and you square it, you get 4. If you have an x value of -2 and you square it, you get 4 again. This is going to be the quadratic function or the parabola. And actually, chapter 3 is about nothing but quadratics. So everything in chapter 3 is all quadratics. So we'll really dive into that deeply when we get to chapter 3. Again, fill out the domain and range for your embedded question. The square root function next is going to be the square root of x. If you take the square root of -1, that's undefined. You cannot take the square root of a negative number, but you can take the square root of 0 and you can take the square root of 1. It's not quite enough, though, to give us what we need. So I often ask for the next number that is a pretty square root, and that wouldn't occur until the number 4, because the square root of 4 is 2. So that's the next one that I'm going to plot then. And what you end up having is a graph. It kind of looks like half of a parabola that's been tipped over on its side. Parent number 4 is the cubing function, so this is going to be x cubed. If you take -1 and cube it, you still get -1. 0 and 1 cubed are going to be 0 and 1. So if you graph those, you have the coordinate 0, 0, 1, 1, and -1, -1. It actually looks a whole lot like the identity function at this point. So we need a little bit more in our graph here. So I think about the number 2. If you cube 2, you get 8. So that's going to be all the way up here. And if you cube a negative 2, that's going to be at negative 8. So what you end up with, the right-hand side kind of looks like a skinnier parabola, half of one anyway. The left-hand side is going down, also having that shape of an upside down, half of a parabola. This is the cubing function. Then number 5, we have the cubed root function. And so the cubed root of -1 is -1. The cubed root of 0 is 0, and the cubed root of 1 is +1. So as we plot these, once again, I have those same 3 coordinates that I had in the identity function and the cubing function. So what I do on this one is think about what's the next pretty cubed root number, and that's going to be 8. The cubed root of 8 is 2, so I'm going to go all the way down to 8. And the cubed root of -8 is going to be -2. So we will go ahead and connect the dots here to get our cubed root function. The last parent is going to be the absolute value function. And you remember the absolute value bars. The absolute value of -1 is +1. Absolute value of 0 is 0. Absolute value of 1 is 1. So we have here, oops, I didn't mean to erase that. We have 0, 0 and 1, 1. We also have -1, 1. This looks like the squaring function did at first. So think about a few more. The absolute value of 2 is 2, 3, 3, 4, 4. On the negative side, the absolute value of -2 is +2. -3 absolute value is +3, etc. This guy, and it should be pretty obvious as to why it's called this. This guy is called the V-graph. So it should be, like I said, it's pretty obvious why it's called the V-graph. And I will end with some cute dance moves that has some of these on there, plus a few more that we will do this semester later on, and some that we would do in Math 111, which is a trigonometry course. So just a couple of cute little things there to take a look at. So again, make sure you have your embedded questions answered so that you can fill those in for my math lab.